Until recently, batter ability has been assessed by metrics that consider the outcomes of at-bats, such as outs, singles, doubles, triples, and home runs. However, these outcomes are not always fully determined by the ability of a batter, and a batter can get lucky or unlucky in a given at-bat. This is why when Major League Baseball introduced Statcast, excitement grew among baseball analysts. Statcast uses high-speed cameras to track player and ball movements and allows for attributes of batted balls to be measured. For instance, this plot displays the outcome of batted balls with particular launch speeds or velocity of the ball off the bat, and launch angles, or vertical angle of the ball off the bat. We can see that this region, from about 20 to 40 degrees of launch angle and at about 100 miles an hour of launch speed, we observe a lot of home runs. In our project, we used features like these and many more collected from baseballsavant.com from 2017 to 2019 to create a random forest that predicts the outcomes of batted balls. We can see our random forest did very well at predicting home runs and outs, and did marginally well to poorly at predicting other outcomes. In order to use this model to assess batter quality, we use simulation to generate predicted probabilities of each batted ball given its attributes. Then we use these probabilities to generate an expectation of wOBA, a commonly used statistic that is a weighted average of outcomes for each player in each year. In these tables, we see that our expected wOBA value, which we call rfxwOBA, correlates marginally better to the following season's actual wOBA than that season's actual wOBA does. It also correlates better than a similar statistic from baseballsavant.com, which we call BSX-wOBA. We also see that rfxwOBA correlates better to itself in the following season than wOBA, and is about as reliable as BSX-wOBA in this sense. In this plot, we see how this information can be applied. This is a distribution of a player's rfxwOBA in a given season. In this case, it's Mike Trout in 2019. We can see the blue line is the average of this distribution, the green line is the BSX-wOBA, and the red line is his actual wOBA from that season. This plot could give a GM an idea of how well they expect Mike Trout to perform in future seasons.